In this video, we're going to answer questions in section A and section B of the practice test. So we'll get started. In the first section, we have short integrals. And the first question has 2 plus e to the x over 2x plus e to the x plus 3. And immediately we should recognize that the derivative of the denominator is the numerator. So we're looking at a question that we have a du over u form. Again, because if we take the derivative of 2x plus e to the x plus 3, we get exactly the numerator. So if we did u substitution, this is what we're looking at, so we can directly write the answer here, the natural log of the denominator. And we should be familiar with that form. Example 2a then. We have tan x secant squared x, and we actually have two approaches we can do with this one. We can recognize that the derivative of tan is secant squared, so instantly we're looking at u and du, and we can integrate immediately. Or we can also consider this tan times secant, in which case the derivative of a secant is the tan secant, and it's a different way to consider u and du. We'll do the first one because it's probably more straightforward. So u du, this is our u, so we get tan squared of x over 2 plus c, simply by integrating this. 3 now, we have 3x squared e to the x cubed, and this form now is e to the u du, because the derivative of the exponent, x cubed, is 3x squared. Again, we can immediately write the integral like this, e to the x cubed plus c, where the derivative of this would give us our original question. The final question here now, just to practice our standard rules, we have the integral of 1 over x. Well, we should recognize that as the natural log of x, plus 1 over x squared. Well, that's x to the minus 2, so that gives us x to the minus 1 over minus 1, minus 3x, x to the 5 had to come from x to the 6, so x to the 6 over 6, all plus a constant. And we'll go ahead and simplify a little. We'll add the negative, put 1 over x there, and make that x to the 6 over 2. And that would be the simplified form of that one. Moving on to the second part then, these are going to be integrals that are a little less straightforward. So sine cubed of 2x, cosine squared of 2x. Well, we've seen questions where we have an odd power or an even power of sine and cosine. And we should know then, if we have the odd sign, we're going to keep one sign. So what we're going to do is we're going to write it again as the sine squared of 2x, the cosine squared of 2x. We're going to take that extra sign and write it as the sine of 2x dx. And this will be what we're going to use for du. And that means we're going to have to replace all the signs here to get cosines. Of course, we should know a sine squared can be replaced by 1 minus the cosine squared of 2x times the cosine squared of 2x times sine of 2x dx. And again, I put this in brackets because we need to remember that's going to be our du. So if we're going to do our u substitution here on the side, our u is going to be the cosine of 2x. That makes du minus sine of 2x dx multiplied by 2. So I'm going to make a 2 in front here. Multiplied by 2 from 2x here. And that just really reminds us that when we do this now, we're going to have to divide this by negative 2 because the only thing that we have is sine 2x dx. And we go ahead and make this substitution. I'm also going to multiply in one step here to save space. So So we get minus 1/2, and that's from du over minus 2. Integral of the u, or cosine squared, is going to come in, so this is going to be u squared minus u to the 4, and everything else left over here is du. And we're almost finished, so we can integrate now. Minus 1/2 times u to the 3 over 3 minus u to the 5 over 5 plus a constant. And we can multiply through the half and substitute. We end up with, so we're going to put cosine 5 2x in front just because it's positive, and that's now going to be over 10 because we're going to bring in that extra 2. It's going to be minus cosine of 3 2x over 6 and plus c. We don't need to multiply the c by 1/2 because it's already a constant. And so there's our final answer for that one. So a little more work, but we're still using the u substitution idea. B2 then, tan inverse in the numerator. We have 1 plus x squared in the denominator. This is actually a straightforward one. Hopefully you recognize it. It's in here because it looks a little trickier. But tan inverse of x, the derivative of that is 1 over 1 plus x squared dx, which is the piece that we have left over. So this is simply the integral of u to the 3 du. And we can go ahead and solve this in a couple of steps here. Add 1, divide by the same for the exponent to get u to the 4 over 4. Replace u, and the final answer is tan inverse of x to the power of 4 over 4 plus a constant. And so that's B2, and we'll keep moving. In B3 we see we have tan cubed. In order to solve tan cubed, hopefully we remember that we need to separate it as tan x and tan squared of x dx. Now we're going to replace tan squared using the identity with secant, so that's going to be tan x times 1 times secant squared x minus 1 dx. And now we've almost got the answer again. The integral of tan x secant squared we actually saw in part A, and we should know how to do that, and there's 2 ways we can look at it. And then that's going to be minus the integral of tan x dx. And we should know that, or we should be able to find it on a formula sheet. So here we end up with tan squared x over 2, direct u du, so u to the 2 over 2, minus, and the integral of tan is actually negative, so we're going to make positive here, natural log of the cosine of x plus c. And we can take that from the formula sheet, or if we've worked it out enough, we should be able to see where that came from. So that's the integral of tan cubed of x. The last example in part B then looks like a particularly tricky example, but we have to remember, if we can't see a way that we can integrate it right away, we need to make a change. And in this case, the change we're going to make is going to be like this. We're going to keep the numerator the same. I'll put the dx up there. As soon as we see that we have a sine combination in the bottom and a cosine on top, we should be thinking u substitution. Sine squared plus 4 sine plus 4 should jump out at you as something that can possibly be factored, and indeed it can. It's the sine of x plus 2 all squared. It's a perfect square. And then that's all to the power of 1/2. But that's the square root sign. And that we should be able to see simplifies to this very nice integral 3 cosine x over sine x plus 2. The 2 and the 1/2 cancel, put the dx there, and now we have u in the bottom, du in the top. Even without writing it, we should be able to see that that's going to be 3 from here times the natural log of the denominator plus a constant. And if you don't see how to do that in one step, write your u substitution here. U equals sine x plus 2, du equals cosine x dx, and that will eventually lead you to the same solution. So that's part A and part B. In the next video, we'll do part C.